In this lesson, we're going to look at solving radical equations, and this will be part one of this lesson. And in part one, we're going to look at the simple kinds of radical equations. And then in part two, we'll look at a few that are a little bit more challenging, but you have enough information, enough background knowledge to be able to do parts one and two very easily. Okay, so first of all, let me remind you about what a radical expression looks like. Okay, so you've had this before, radical expression. Radical expression. So radical expression looks something like this, the square root of 2x minus 5. Okay, so that's a radical expression. It contains a index, which in this case the index is 2, hence the idea of square root. And then 2x minus 5 is the radicand, and then this is the radical. So remember, this symbol right here is called the radical. And in this case, it's square root. Okay? The 2x minus 5 we call the radicand. And then the index, you remember if there's no number there, it's understood to be a 2. So this right here would be called the index. Okay, so the index is 2. Okay, so another example of a radical expression would be the cube root of 5x, right? So 3 is your index, so the index is 3. Index is 3. The radicand is 5x, right? Okay, and then the cube root, that's the radical symbol. Radical symbol. Okay? Now, so those are radical expressions. Now, a radical equation has an equal sign. Radical equation. So, for example, the square root of x plus 5 is equal to 2. That's a radical equation. The cube root of x equal 7. That's a radical equation. All right, so you have a radical expression, regardless of what the index is. If the index is 2, 3, 4, whatever it may be, you have an equation because that's an equal sign. All right? And it doesn't always have to be just constants on the other side. Another example would be the square root of 3x minus 1 equal x plus 2. That's a radical equation. So all these are radical equations. You can have variables on both sides. You can even have radicals on both sides. All right? Another example would be the square root of 5x minus 2 equal the square root of x minus 1. All right? So those are examples of radical equations. So I gave you 4 examples. Okay, what we want to do, though, is learn how to solve a radical equation. So let's talk about that, how to solve a radical equation. All right, so let's start with a very simple example. So let's start with this one. Okay, so this will be a simple example. All right, so number one, let's solve this. So we have this radical equation, make it as simple as possible. The square root of x is equal to, let's say, 3. All right, the square root of x is equal to 3. I made that so simple to where you can look at this and tell me what the solution is without even doing any algebraic manipulation. So the square root of what number is 3? All right, think about that. Think about what I'm saying. You've had square roots before. The square root of what number is 3? All right, if you said the square root of 9 is 3, you're all right. So the solution is x equal 9. That's very good. That's correct. All right, let's look at number 2, though. What if I had this? The cube root of x is equal to, let's say, 2. The cube root of x is equal to 2. Okay, well, you've dealt with cube roots before. The cube root of what number is 2? In other words, what's the solution? Solution is x equal, what's the solution? X equal what? Is the cube root of what number is 2? All right, so remember how we did this before. You said the square root of 9 is 3 because 3 times 3 is what? 9. All right, the cube root of what is 2? Now remember, 2 times 2 times 2, cube root. So what do you think that is? 8. Yep, so x is 8. The cube root of 8 is equal to 2. Okay, But I want you to think about something. Okay, so you did these two without no algebraic manipulation at all. But I want you to think about this. Remember when solving an equation, whether you go back to last semester or things that we've done in this course, when solving an equation, in this case, you're trying to get the variable x by itself, right? Which we did, x equal 9. So I got the variable x by itself. Well, this is a little bit more difficult to do without thinking about what's happening here. So you see I'm taking the square root of x, right? What do you think is the opposite of taking the square root? Or what is the opposite of taking the cube root? That's what we've got to think about. What is the opposite of square root? What's the opposite of the cube root? All right, so the opposite of square root is to square, and the opposite of cube root is to cube. Okay? So I'm going to go back over here, and I want you to think about this. All right, now, you see right here? See this right here, right? Okay? Now I'm going to ask you this. Do y'all remember from a previous lesson, what is the square root of x times the square root of x? All right, well, the square root of x and the square root of x is the square root of x squared, right? And what's the square root of x squared simplified? It's just x. So I have the square root of x, so if right now I'm square rooting, right? So if I square, I remember what you do to one side, you have to do to the other. If I square both sides, this is this, right? And the square root of x and the square root of x is just x. Well, it turns out that the square root and the square are inverses, so they undo each other. So you're just left with the radicand. So what's this radicand? X. And what's 3 times 3? 9. Okay? Over here, let's think about that. Let's look at this right here. The cube root of x equal 2. What's the opposite of cube rooting? Cubing. So if I cube both sides, and I want you to also think about this. You see this index is 3? What am I raising both sides to? 3. But what you do to one side, you have to do the other. What's this index right here? 2, right? So what did I do to both sides? I squared both sides. All right? So what's the cube root of x cubed? So what's the cube root of x times the cube root of x times the cube root of x? All right, is what I'm saying. So think. The cube root of x times the cube root of x times the cube root of x. Well, isn't that the cube root? And what's x times x times x? X cubed, right? And so 3 divided by 3 is 1, so you just get x. So the cube and the cube root undo each other, so you're left with the radicand, so x equal, and what's 2 times 2 times 2? 8. All right, so that takes us to the steps to solving a radical equation. And in this lesson, we're going to focus on square roots. We're going to focus on square roots in this lesson. All right, so here are the steps. Okay, so before we begin, just remember that your index is this root right here. All right, so the index or root right here. The ax plus b, whatever's under the radical symbol, is your radicand. Okay, so keep that in mind. All right, so here are the steps. And I'll come back to the steps in a little while. Let's look at this example as we go through the steps. All right, suppose I want to solve this equation. The square root of x plus 5 is equal to 3. Okay? X plus 5 is equal to 3. All right, step 1. You're going to isolate the radical. Isolate the radical. In other words, get the radical by itself. Well, if you look at this, isn't the radical already by itself? It sure is. All right? Then I need for you to identify the index. What's the index? The index is 2. Okay? All right, I'm going to go ahead and rewrite this over. All right, the index is 2, right? So the next step, remember what we did here? Once I realized the index was 2, what did I do to both sides? I squared both sides. Once I realized the index was 3, what did I do to both sides right here? I cubed both sides. Okay? All right, so listen to this now. So, what's the index? 2. So what do I do to both sides? What's the next step? I raise both sides of the equation to the nth power. So I square both sides, just like this. Okay? And then we're going to use step 3 is to isolate the variable, get the variable by itself. So we're going to use algebraic techniques, whether it involves factoring, combining like terms, solving a linear equation, things like that. And if we need to, we may have to repeat steps 1 and 2. Now in part 1, we won't need to repeat. We'll just go to step 4. Okay? All right, so when I square both sides, I want you to remember this. The square and the square root will undo each other. So that goes back to what happens here. So when you have a square root of a radicand times the square root of that same radicand, the answer is just a radicand. All right, same thing here. Cube root multiplied by itself 3 times is just a radicand. Oops. Right here, it's just a radicand. Okay? Remember, the radicand is x. When you multiply the cube root by itself 3 times, it's just a radicand. So, the square and the square root undo each other. So what's the radicand? What's left on this side? X plus 5. And what's 3 squared? 9. And notice I went from a radical equation to what kind of equation? What kind of equation is this? This is a linear equation. And now we solve a linear equation. So in step 3, so step 1 was to isolate the radical, which it already was. Step 2 is to raise both sides to a power equal to the index, which I did. And then step 3 is to solve. Okay? So to get x by itself, I'm going to subtract 5 from both sides. Combine like terms. I get x to be 4. Okay? And let's check. Let's check this. And by the way, when solving a radical equation, whenever you raise both sides to an even power, right here, whenever you raise both sides to an even power, you must check your solutions. And sometimes when you raise both sides to even power, you can introduce what's called extraneous solution or false solutions, and we're going to talk about that in part 2. So in part 1, you have to worry about these false solutions, so to speak. Okay? All right, but let's check. Since I raised both sides to an even power, let's check. Now you always go back to the original problem. So the original problem was this. And then I'm saying that the solution is 4, right? So let's check it. The square root of 4 plus 5. And the square root of 4 plus 5 is the square root of 9. And it's the square root of 9 equal to 3? Yes, it is. So that's your solution. Okay? Number 4. Suppose in number 4 we had the square root of x minus 5 is equal to 1. X minus 5 is equal to 1. All right, what's the first thing you should do? First thing you should do, remember the steps. The steps of solving a radical equation is to make sure you get the radical by itself. Get the radical by itself. So is the square root of x by itself? No. So I need to get rid of this, subtract 5. So I'm going to add 5 to both sides, just like this. So I get the square root of x is equal to 6. Now what's the next step? The next step, remember, to get rid of a radical, you're going to raise both sides to a power. And we're going to say the nth power. The nth meaning the index. Okay? So, what's the index here? Square root. What's the index? 2. So I'm going to go ahead and rewrite this over. I'm going to square both sides. And when I square both sides, remember the square and the square root undo each other, so you're left with the radicand. What's the radicand? X. And what's 6 times 6? 36. Okay? All right, so let's check. Go back to the original. Here's my original. And I'm saying x is 36, right? So let's check. The square root of 36 minus 5. And the question is that equal to 1? But what's the square root of 36? Square root of 36 is 6. And what's 6 minus 5? It is 1. So that's right. Okay? Number 5. Suppose I had the square root of 2x minus 3 plus 1 is equal to 5. The square root of 2x minus 3 plus 1 is equal to 5. All right, I want to solve this radical equation. You've got to notice that's a radical equation. In fact, it's a square root. And so for us, we'll be focusing on square root equations. What is the first step to solving a radical equation? First step to solving a radical equation is to isolate the radical, get the radical by itself. So when I get the radical by itself, I'm going to have to subtract 1 from both sides. And so I get the square root of 2x minus 3 is equal to 4. Okay, so that's where I'm at. So notice I made this radical equation a little bit easier to deal with. Okay, now the next step, once you get the radical by itself, the next step is get rid of that square root symbol. So how to get rid of the square root symbol? I raise both sides to the nth power. So what's the index? The index is 2. So I'm going to square both sides. So I'm going to square both sides just like this. And then remember, I need to remember this, the square and the square root undo each other. The square and square root undo each other. Okay? So meaning that all you're left with is a radicand. And what's the radicand? 2x minus 3. And what's 4 squared? 16. Okay? All right. Next step is to solve for x. So notice I have this linear equation. So that's a linear equation. To solve a linear equation, you're going to add 3 to both sides, right? So I get 2x equal 19. And then divide both sides by 2. I get x to be 19 halves. Okay? All right, so that's my solution. Now let's check it though. Now let's check. So remember, when raising both sides to even power, you are going to have to check. Now, in this case, if you forgot to check, it's no big deal, only because when you look at your equation, the variable expression only occurs on one side, and it's here, and this is positive. All right, so we're going to do one in a little while where if you're not careful, you will mess up. So let's go ahead and check this. So let's check. All right, so I'm going to check. I'm going to get I'm going to write the original problem over. All right, and where we see the variable x, I'm going to substitute 19 halves. Okay, so I'll get 2 times 19 halves minus 3 plus 1, and I want to see if that's going to equal that. Okay? All right, well, what is 2 times 19 halves? Well, the 2's divide out, so you're left with 19, right? So I get the square root of 19 minus 3 plus 1. What's 19 minus 3? 19 minus 3 is 16. And what's the square root of 16? Square root of 16 is 4, and is 4 plus 1 equal to 5? Yes, it is. Okay? So 19 halves is the solution. Okay, number 6. So again, in part 1 now. Okay, so in part 1, remember what we're focusing on. In part 1, where we're solving radical equations, we're focusing on square root. I know we did a cube root, but we're focusing on square root. And what we did was you had to make sure that the radical is by itself. Once the radical is by itself, I raise both sides to the second power because that's the index of the radical, square root 2. All right. And then the other thing you got to remember is this. If you raise both sides to an even power, and you're going to see this in part 2 in particular, if you raise both sides to even power, which I'm doing all along here, you have to check, okay? Because in part 2, we're going to talk about an extraneous solutions. We're going to talk about what that means. Okay, now let's look at number 6. All right, so you try, pause the video and see if you can do number 6. And if you can do something like number 6, you should be fine for your test and your final exam on this. On part 1. Okay, so let's suppose we had the square root of 3x minus 7 minus 2 equal 5. Okay, so the square root of 3x minus 7 minus 2 equal 5. All right, so think about your steps. What's the first step? Okay, so the first step is to isolate the radical, right? Step 1, isolate the radical. So I'm going to add 2 to both sides. And so I get the square root of 3x minus 7. That's minus 7 right here. combining like terms, the 2's cancel out, and you're left with 5 and 2, which is 7, correct? All right. Now, once I get the radical by itself, what is the next step? The next step is to raise both sides to the nth power. Well, we're dealing with square roots, so it's always going to be raise both sides to what power? The second power. So we're going to square both sides. All right, so I'm going to do this, just like that. And then you got to remember that the square and the square root will undo each other. So you're left with the radicand. What's the radicand? 3x minus 7. And what does 3x minus 7 equal to? 49. Okay? Now notice I went from a square root equation to what kind of equation? So this is a square root equation. Okay? And I solved the square root equation like this, but then I ended up with a linear equation now. So that's a linear equation. So how do I solve this linear equation? Well, I got to get x by 7. So I'm going to add 7 to both sides, right? Add 7 to both sides. And combining like terms, I get 3x equal 49. And 7 is, what's that, 55? Is that, I'm sorry, 56, right? Okay. Then divide both sides by 3. So I'm going to divide both sides by 3. I get x to be 56 divided by 3. Now 56 divided by 3, that's not a whole number. Okay, so I'm going to have to leave it like that. So it's x equal 56 divided by 3. I can't reduce it. All right, so 56 divided by 3. If you put that in your calculator, you'll see you won't get a whole number, right? Okay, and then it's not reducible, so you're done. That's all you can do to this. Okay, now let's check, though. I raised both sides to even power. Okay, so let's check our answers. Now, we hadn't talked about this yet, but it says eliminate any extraneous solutions from the final answer. That's going to be part 2. That's going to be part 2. Okay, let's check. I have the square root of 3x minus 7. Let's do it again. 3x minus 7, subtract 2 equal 5, right? Always go back to the original, because you could have made a mistake somewhere along the way. All right, always in the original. So wherever you see the variable x, I'm going to substitute 56/3. So I get the square root of 3 times 56 divided by 3 minus 7. And whatever that is, I'm going to subtract 2, and I want to see if that's going to equal 5, right? That's my question. That's what you're looking for. Well, what is 3 times 56 divided by 3? Well, the 3's divide out. Y'all agree? So that's 56. And what is 56 minus 7? And then remember, we're subtracting 2. I want to see if that's going to be 5. Well, 56 minus 7 is 49, right? And then, and don't forget you're subtracting 2. What's the square root of 49? 7. And what's 7 minus 2? It is 5. Okay? All right. Okay, so let's look at this one now. All right, now, let's go back to an easy kind for a moment. Let's go back to an easy kind. I have the square root of x is equal to, let's say, 4. Okay? You can look at this without doing any work to tell me what x is. The square root of what number is 4? 16, right? Okay, good. So x equals 16. No big deal. What if I had this? The square root of x equal negative 4. Think about that. Square root of x equal negative 4. Right away, some of you are going to say negative 16. It's not. Because you got to remember from a previous lesson, so the answer is not x equal negative 16. Okay? Because think about that. The square root of a negative 16 is not a real number. You remember that from a previous lesson? Because no real number times itself is negative. A real number times itself is either positive or 0, never negative. Okay? So when I take the square root of radicand and I get a constant on this side and it's negative, that's not possible. Okay, so let's go back over here now. You saw how I raised both sides to even power, just like this, and then the square and the square root undo each other, so you got x to be 16, right? And then we check. Do you remember that? We check. So I'll go back to the original equation, which was this, and where we see the variable x, is substitute 16. Is the square root of 16 equal to 4? Yes, it is. Square root of 16 is 4. Now let's go do the same thing here. If I square both sides, just like this, the square and the square root undo each other, so I get x. Now what's negative 4 times itself? Positive 16. Y'all agree? Okay, so let's go back and check now. So let's check. Is the square root of 16 equal to negative 4? That's the question. Is the square root of 16 equal to negative 4? No, it's not. The square root of 16 is equal to what? Square root of 16 equals a positive 4, not a negative 4. So the point being this, when you have a square root on this side, just like this, and on the other side you have a negative number, not a number, a constant, okay? It's negative, then that's not a real number. X is not a real number, okay? So your solution, you're going to say solution, you're going to say not a real number. Not a real number, okay? All right, now let's look at number 9. So that's going to be similar to the one that's going to be in my math lab. So number 9, let's suppose we had this. All right, so let's suppose this is number 9. So we have the square root of x plus 5 plus 3 equal 1. Okay? Square root of x plus 5 plus 3 equal 1. Okay, so what's the first step? First step is to get the radical by itself. So I'm going to subtract 3 from both sides. All right, so I get the square root of x plus 5 equal negative 2. Okay? Now, at this point, some of you are going to recognize that I have a square root here, right? And I have a negative constant on that side. So some of you right away are going to say there's no solution. All right? Because the square root of this must be positive or 0. This is negative. Some of you will not see this. So some of you are going to do this now. Some of you are going to square both sides, and that's okay. You're going to square both sides. That's fine. Just like this. Okay? And so when you square both sides, the square and the square root undo each other, so you get x plus 5 is equal to 4, because negative 2 times negative 2 is 4. And then you're going to solve this linear equation. So you're going to subtract 5 from both sides, right? So you get x to be negative 1. But you got to check. You must check. You must check. All right, so go back to the original. Always go back to the original. So the square root of x plus 5 plus 3, and I want to see if that's going to equal 1. Well, I'm saying x is negative 1, so I get the square root of negative 1 plus 5, right? Plus 3 equal 1. So that's what I want to see if that's equal. Well, negative 1 plus 5 is what? 4. So I get the square root of 4 plus 3. What's the square root of 4? Square root of 4 is 2. And what's 2 plus 3? That's 5. Is that this? No, it's not. That's not that. So what you're going to say now is that there is no solution. There is no solution. In my math lab, you're going to say there's no solution. Okay? So there's no solution. All right, number 10. What if you had this? The square root of 2x minus 3 plus 3 equal, let's say, 4. Okay? What's the first step? First step is to get the radical by itself. So I'm subtract 3 from both sides. When I do that, I get the square root of 2x minus 3 equal 4 minus 3 is 1. Okay? And I know I can go further because that constant is positive, right? I can go further. So let's go further. So I'm going to square both sides. So I'm going to go ahead and rewrite this over. Square both sides. And so I get the square and the square root into each other. So I get 2x minus 3 equal 1 times 1 is 1. Adding 3 to both sides, I get 2x equal 4. So notice I went from a square root equation to at this point right here, a linear equation. All right, so this is your square root equation. And when I did all this stuff, when I raised both sides to the second power to get rid of the square root, I ended up with a linear equation. And I'm solving a linear equation. So I divide both sides by 2, and I get x to be 2. You have to check. Let's check. How do you check? You go back to the original equation. The original. Okay? And wherever you see the variable x, you're going to substitute 2. So I get the square root of 2 times 2 minus 3 plus 3, and I want to see if that's going to equal this. That's the question. Well, what's 2 times 2? Okay, 4, right? So this right here becomes this, and don't forget you're adding 3. And what's 4 minus 3? Okay, 1. Okay, what's the square root of 1? 1, and is 1 plus 3 equal to 4? Yes, it is. So 2 is your solution. Okay? All right, what if you had this? And 11. What if you had the square root of 2x minus 3? Okay. Let's say minus 3, well, let's say plus 3 equal, let's say, 1. All right? Okay. So we're going to get the radical by itself. So you're going to subtract 3 from both sides. So I have the square root of 2x minus 3 equal negative 2, right? Now, notice, guys, at that point, you see that negative constant, right? So you know right away there's no solution, right? There's no solution. But let's suppose you didn't see this and you go further. Okay, let's go further. Let's square both sides. Just like this. Square both sides, just like that. Remember, you raise both sides to a power equal to the index. So the square and the square root undo each other. You're left with the radicand. What's the radicand? 2x minus 3 equal, and what's negative 2 times a negative 2? Negative 2 times negative 2 is a positive 4. All agree? All right. So then I went from the square root equation to a linear equation. So I'm going to add 3 to both sides. So I get 2x equal 7. Divide both sides by 2. I get x to be 7 halves. Okay, 7 halves. Okay, let's check it. How do you check? Go back to the original equation. Here is the original equation. You must go back to the original. So in place of the variable x, I'm going to substitute 7 halves. So I have this. I have the square root of 2 times 7 halves minus 3 plus 3, and I want to see if that's going to equal 1. That's what I'm looking for. Well, what is 2 times 7 halves? Well, 2 times 7 halves, the 2's divide out. You're left with 7. So I get 7 minus 3 plus 3. 7 minus 3 is 4. So I get the square root of 4 plus 3. What's the square root of 4? Well, the square root of 4 is 2. And what's 2 plus 3? Well, that's 5. Is that equal to this? No. 5 does not equal 1. So 7 halves, x equals 7 halves, is not a solution. So we say no solution. Okay, no solution. Okay? All right, so that was number 11. All right, and then finally number 12. Number 12. So part 1 is the easy kind. All right, number 12. We'll do one more. Number 12. Suppose I had this. Okay, now be careful with 12. I want you to be careful. So let's suppose I had 9 minus the square root of x plus 2 is equal to 5. Okay? 9 minus the square root of x plus 2 is equal to 5. Okay, so I got to get the radical by itself. So I got to get rid of this 9 first. All right, so that's a positive 9. So I'm going to have to subtract 9 from both sides. All right, 9 minus 9 is 0. Y'all agree? But be careful, don't say that's the square root of x plus 2, because what you see in front, negative. That's a negative there, okay? So be careful. Equal, and what's 5 minus 9? Well, 5 minus 9 is a negative 4. All right, now, if you're not careful, you're gonna get caught up in what we've been talking about here. You're gonna say, oh, well, there's a negative constant on the other side, so I can say there's no solution. That's not true here, because see, this is a positive square root right here. A positive square root does not equal negative. Does not equal a negative number. See, this is a negative square root, right? So what you want to do is get that square root of x plus 2 by itself. You need to get that square root of x plus 2 by itself. So I want you to remember something. Do y'all recall when you had negative x equal 5, let's say. Okay? Well, let's do negative 5. Negative x equal negative 5. Do y'all remember that you wrote negative x as negative 1 times x equal negative 5? And then to get x by itself, you divided both sides by negative 1, just like that. Negative 1 divided by negative 1 is 1. 1 times x is x. And a negative divided by negative is a positive, so you get positive 5. Okay? We'll use that same idea here. So do y'all see I can write this as negative 1 times the square root of x plus 2 equal negative 4? And if I want to get that square root of x plus 2 by itself, right now I'm multiplying by negative 1. The opposite is to divide by negative 1, right? Okay? So negative 1 divided by negative 1 is 1. 1 times the square root of x plus 2 is the square root of x plus 2. And what's a negative 4 divided by negative 1? A positive 4. All right, so I got this to look like 10, okay? Now I do all of this. Okay, so now I'm going to square both sides. So that was a little bit tricky. You got to remember something like this. Usually the one in your final exam or a test is not it doesn't look like this. It looks more like number 10 or number 8, something like that. Okay, so we're going to square both sides. I'm going to rewrite this over. And when I square both sides, the square and the square root into each other, so you get x plus 2 the radicand equals 4 times 4 is 16. Subtract 2 from both sides, I get x to be, what's that, 14? You're done. X is 14, but we got to check though. Let's check. Okay, let's check. Where do you check? Where in this process do you check? That's correct. You check the original. So write the original over. Always go back to the original. Okay? That's the original. So wherever I see the variable x, I'm going to substitute 14. So I get 9 minus the square root of 14 plus 2, and I want to see if that's going to equal 5. Well, what's 14 plus 2? All right, 16. So I get 9 minus the square root of 16. Well, what's the square root of 16? 4. And is 9 minus 4 equal to 5? Yes, it is. So x equal 14 is a solution. Okay? All right, so that is the part 1 lesson on solving radical equation. And remember, we're looking at square roots in particular. And notice that every time in part 1, I want you to notice this, in part 1, we always went in part 1 now, we always went from a square root equation to what kind of equation? Linear. Okay? So remember, in part 1, we went from square root equation to what kind of equation? Linear. All right? And remember the steps is you isolate the radical, then you raise both sides to the second power because that's the index, right? And then you solve. So you're solving this linear equation, and then you check. You must check. Okay. All right. So, but in part 1, pay attention to the fact that we went from a square root equation. We went from a square root equation to a linear equation, and then keep in mind that in part 1, you also saw that like in this case, there's no solution. Okay? All right. So that's going to take care of the lesson for part 1.